Okay, so for item 10, we're dealing with a non-empty family of sets, A. And for item A, we're supposing that B is a subset of A for every A belonging to the family. So every single set of that family has B inside it. And we want to show that this B is a subset of the intersection. So whenever we're trying to show that something is a subset, we're going to take some element that is in B and show that that element must also be there. So we're going to say, suppose that B is a subset of A for every A belonging to the family. Now we're going to take some element that is in B, so let X belong to B. As B is a subset of A, then for every A belonging to the family, X must belong to A. Since X belongs to B and B is inside every A, then means that X is also going to be inside every A belonging to that family. And so this here, so we're saying for every A belonging to the family, X belongs to A. So this is the definition of the intersection. Thus, X belongs to the intersection by definition for every A. So we took some X that was in B and then we showed that that X was in the intersection. So our conclusion is going to be, therefore, B is a subset of that intersection. And that is it for item A. So item B, they want us to decide what is the largest set X such that X is a subset of A for every A belonging to the family. So let's draw a situation here. So suppose that the family has 3 sets, right? Maybe you can say that this is going to be, so maybe this is A1, that is A2, and that is A3. So we're looking for the largest set X such that X is a subset of every single one of these. So whatever set we find, it has to be inside A1, A2, and A3. So already here, we can see that A1 and A2 and A3, what they have, all 3 of them have in common is this part here. And this is the intersection, right? This is the intersection of A belonging to the family. That is the intersection. So it must be the case that X is inside, it's inside this little area here. So now the question is, what is the largest set X that can be inside here? That is, find a set X such that X belongs to A for every A in the family. So we have drawn the possible area here, and we're saying that, hey, if V is a subset of A for every A belonging to the family, so maybe we can say that if this is the set, maybe we can say that this is V, right? Then V has to be inside X. So we can see here that if we call X this entire area in yellow, then any other subset that is part of A1, A2, and A3 is going to be inside it, right? Like maybe V is this other guy here. Well, that's still inside X. Maybe V is this, still inside X, right? So you can see that the largest possible set that fulfills all this criteria is actually the intersection. So the answer here is going to be the intersection of the family. And that's it for item B. Now for item C, we're supposing that A is a subset of D for every A belonging to the family. So every single set in that family is also inside some other set D. And now we want to show that the union is a subset of D. So similarly, we're going to take some element that is here and then show that that element must also be there. So we are going to say, so for item C, we're going to say, suppose that A is a subset of D for every A belonging to the family. So now we're going to take some element that is in the union. So we're going to say let X belong to the union. So union over A. And we want to show that that X must also be in D. Then X belongs to A, right? Actually, no, maybe let me rewrite this. Then there exists some A belonging to the family, because of the definition of the union, such that X belongs to A. Note that A is a subset of D for every A. So if X belongs to A and every single A belongs to D, so the conclusion is going to be X belongs to D, right? And so what happened here was we took some X that was in the union and we showed that that X must also be in D, because if it's in the union, then it belongs to some A, but every single A is inside D, so X belongs to D. Therefore, our conclusion is going to be, therefore, the union is a subset of D. That's it for item C. And for item D, it's going to be kind of a similar idea to item B, but now we're looking for the smallest set Y that fulfills certain criteria. So once more, let me draw maybe 3 sets belonging to the family, right? This is just an abstraction, doesn't mean that the family has 3 sets. So that's going to be A1, A2, and A3. Maybe I'm going to move this around to the left. Okay, so we're looking for now the smallest set Y such that A is contained in Y for every A in the family. So what we're saying here is that, hey, A1 has to be inside that Y, A2 has to be inside that Y, and A3 has to be inside that Y. So every single thing in all these sets have to be contained, right? So Y has to be at least, it has to contain this, that, and that. Because if Y is this big, then it's going to have A1, A2, and A3 inside it, right? And so we're saying that, hey, A, the 2 condition is A is a subset of Y for every A belonging to A. So check, we have done that here. And we're saying that, hey, if A is a subset of W for every A belonging to the family, then Y is a subset of W. And what do we mean by that? Well, I could have drawn, like I can draw some W here, right? And if I do this, then A1, A2, and A3 are inside that W. But we can see here that W is not the smallest set, right? Because this thing here in yellow, that's smaller than W. So it does fit this criteria that if A is embedded in W for every A, then Y is embedded in W, which we can see here if we define Y to be this yellow stuff. So this is Y, and it truly is the smallest set that contains every single element in A1, A2, and A3. And we can see here that this is actually the union, right? This Y is the union. So if your family had, I don't know, 100 sets, a million sets, whatever, the union would still be the smallest, because you could always construct some set W that is bigger than the union, right? So we're going to say, we have shown here graphically that the answer here, the smallest possible set that contains A1, every single A, is going to be the union of A belonging to the family. So that is it for item D.